According to the National Electrical Code, specifically Section 210.21b3, a 20 amp branch circuit is permitted to supply 15 amp receptacles, general purpose receptacles, luminaires and clock devices. This means using 15 amp receptacles on a 20 amp circuit is generally acceptable, as long as other conditions are met. Let's consider the inspector's interpretation in the scenario. The interpretation appears incorrect based on the provided National Electrical Code sections. The National Electrical Code section 210.21b3 explicitly permits the use of 15 amp receptacles on a 20 amp branch circuit. Importantly, there is no explicit requirement within the National Electrical Code mandating the splicing of wires and the use of pigtails when daisy chaining receptacles, especially on a non-multi-wire circuit. Now let's consider the continuity of the grounding conductor. National Electrical Code section 300.13b specifically addresses multi-wire branch circuits. This section mandates that in multi-wire branch circuits, the grounding conductor must remain continuous throughout the entire length of the circuit. However, this requirement applies exclusively to multi-wire branch circuits. In the described scenario, which involves the standard 20 amp receptacle circuit, the grounding conductor needs to be continuous, but there is no requirement to implement pigtail connections at each individual receptacle. To summarize, the electrician's method of daisy chaining the receptacles using the 4 available screws on the devices complies with the National Electrical Code. The inspector's rejection of the installation, therefore, is not supported by the National Electrical Code. When dealing with electrical installations, it is important to verify all interpretations of the National Electrical Code and to consult with other resources or a more senior inspector if necessary. The National Electrical Code intends to provide electrical safety and is the basis of most electrical inspections. It is important to fully understand it, as it is only for the safety of people and property. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years to reflect changes in technology and best practices. Understanding the NEC is crucial for electricians, inspectors, and anyone involved in electrical work to ensure safety and compliance. Here is some further information about the National Electrical Code and how it relates to electrical installations. Firstly, the scope of the NEC covers a wide range of electrical installations, including wiring, overcurrent protection, grounding, and equipment. It applies to residential, commercial, and industrial buildings as well as outdoor installations. The NEC is not a law itself, but it is often adopted by state and local governments as part of their building codes. Secondly, the purpose of the NEC is to provide a set of minimum safety standards for electrical installations. It is designed to protect people and property from electrical hazards such as fire, shock, and electrocution. The NEC is not intended to be a design manual, but it does provide guidance on how to install electrical systems safely and effectively. Thirdly, the organization of the NEC is divided into chapters, articles, and sections. Chapter 1 covers general requirements, such as definitions and wiring methods. Chapters 2 through 7 cover specific types of installations, such as residential wiring, commercial wiring, and industrial wiring. Chapter 8 covers communication systems, such as telephone and data wiring. Chapter 9 contains tables and examples to help with calculations and design. Here are some key concepts covered in the NEC. Firstly, wiring methods. The NEC specifies acceptable wiring methods for different types of installations. These methods include rigid metal conduit, electrical metallic tubing, non-metallic conduit, and cable wiring. The choice of wiring method depends on factors such as the environment, the type of building, and the voltage level. Secondly, overcurrent protection. The NEC requires that all electrical circuits be protected by overcurrent devices such as circuit breakers and fuses. These devices are designed to interrupt the flow of current if it exceeds a safe level, preventing overheating and potential fires. The size of the overcurrent device must be matched to the ampacity of the circuit conductors. Thirdly, grounding. Grounding is an essential safety measure that helps to prevent electrical shock. The NEC requires that all electrical systems be properly grounded to provide a low impedance path for fault current to return to the source. This helps to trip over current devices quickly in the event of a ground fault, minimizing the risk of electric shock. Here are some specific examples of NEC requirements. Firstly, receptacle spacing. The NEC requires that receptacles be spaced no more than 12 feet apart along walls in habitable rooms. This ensures that extension cords are not needed to reach electrical outlets, reducing the risk of tripping hazards and electrical shock. Secondly, GFCI protection. The NEC requires ground fault circuit interrupter, or GFCI, protection for receptacles in certain locations such as bathrooms, kitchens, and outdoor areas. GFCI devices are designed to detect ground faults and interrupt the flow of current quickly, preventing electric shock. Thirdly, offsite protection. The NEC requires arc fault circuit interrupter, or offsite protection for circuits that supply receptacles in bedrooms. Offsite devices are designed to detect arc faults, which are a common cause of electrical fires, and interrupt the flow of current to prevent fire from starting. To effectively use the NEC, it is important to follow these steps. Firstly, obtain a copy of the latest edition of the NEC. The NEC is updated every 3 years, so it is important to have the most current version to ensure compliance. Secondly, familiarize yourself with the organization of the NEC. Understanding how the NEC is organized will help you find the information you need quickly and easily. Thirdly, read the NEC carefully and pay attention to the details. The NEC is a complex document, and it is important to read it carefully to ensure that you understand the requirements. Fourthly, consult with a qualified electrician or inspector if you have any questions. Electrical work can be dangerous, and it is important to get expert advice if you are unsure about anything. In addition to the NEC, there are other resources available to help with electrical installations. These include manufacturers' instructions, industry standards, and training courses. It is important to use all available resources to ensure that electrical installations are safe and compliant. The NEC is a critical document for ensuring electrical safety. By understanding the NEC and following its requirements, electricians, inspectors, and anyone involved in electrical work can help to protect people and property from electrical hazards. The NEC does not specifically prohibit or endorse the practice of daisy chaining receptacles on a 20-amp circuit using the 4 screws on the back of the receptacle, provided that the installation meets all other applicable requirements of the code. There are multiple considerations related to this that are important to know. Firstly, the integrity of connections. The NEC requires that all electrical connections be made in a way that ensures a reliable and electrically sound connection. If the screws in the back of the receptacles are used to create a feed-through connection, it is essential that these connections are properly tightened and maintained to prevent loose connections, which can lead to overheating and electrical fires. Secondly, ampacity of conductors. The NEC specifies the ampacity of conductors, which is the maximum current that a conductor can carry safely without overheating. The conductors used in the 20-amp circuit must be of sufficient size to handle the load, and the receptacles must be rated for at least 15 amps. Thirdly, device ratings. While 15-amp receptacles are permitted on a 20-amp circuit, it is important to ensure that the receptacles themselves are listed and rated for the intended use. The NEC requires that electrical equipment be used in accordance with its listing and labeling. Fourthly, box fill. The NEC also provides requirements for box fill, which is the amount of space occupied by conductors, devices, and fittings inside an electrical box. When daisy chaining receptacles, it is important to ensure that the box is not overfilled, as this can lead to overheating and damage to the conductors and devices. It is also important to check the local amendments and interpretations. Some jurisdictions may have local amendments or interpretations of the NEC that affect the acceptability of daisy chaining receptacles. It is important to check with the local electrical inspector to determine if there are any specific requirements or restrictions in your area. Now, let's consider some alternative wiring methods. If there are concerns about the reliability or safety of daisy chaining receptacles, there are alternative wiring methods that can be used. These include using pigtails to connect the conductors to the receptacles, or using a junction box to make the connections. The most common wiring methods are the following. Firstly, pigtailing. This involves splicing the incoming and outgoing conductors together with a short length of wire, or pigtail, that is then connected to the receptacle. This method provides a more secure and reliable connection than using the screws on the back of the receptacle. Secondly, junction box. This involves using a junction box to make the connections between the incoming and outgoing conductors. The conductors are spliced together inside the box, and short lengths of wire are run from the box to the receptacle. This method can be useful when there are multiple conductors or devices in the same location. It is also important to note that there are other potential issues to consider when installing receptacles on a 20 amp circuit. Firstly, voltage drop. Voltage drop can occur when the voltage at the receptacle is lower than the voltage at the source. This can be caused by long wire runs, undersized conductors, or excessive loads. The NEC provides guidelines for minimizing voltage drop in electrical circuits. Secondly, ground fault protection. The NEC requires ground fault circuit interrupter, or GFCI, protection for receptacles in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCI protection is designed to protect people from electric shock by detecting ground faults and interrupting the flow of current. Thirdly, arc fault protection. The NEC requires arc fault circuit interrupter, or FSI, protection for circuits that supply receptacles in bedrooms. FSI protection is designed to protect people from electrical fires by detecting arc faults and interrupting the flow of current. To ensure a safe and compliant installation, it is important to follow these steps. Firstly, consult the NEC and local amendments. Review the NEC and any local amendments to ensure that the installation meets all applicable requirements. Secondly, use listed and rated equipment. Use only electrical equipment that is listed and rated for the intended use. Thirdly, make secure connections. Ensure that all electrical connections are properly tightened and maintained to prevent loose connections. Fourthly, consider alternative wiring methods. If there are concerns about the reliability or safety of daisy chaining receptacles, consider using alternative wiring methods such as pigtailing or a junction box. Fifthly, check for voltage drop. Check the voltage at the receptacle to ensure that it is within acceptable limits. Sixthly, provide ground fault and arc fault protection. Provide GFCI and FSI protection as required by the NEC. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector.